Hello dear students, I am Pardeep Koul, lecturer in chemistry, and we are here with your unit, that is P block elements. And in this very unit, our today's topic is phosphine. Phosphine is basically a compound of phosphorus. It is a hydride of phosphorus. Today we shall be discussing its preparation and properties. So let us directly come to its first. Let me come to its molecular formula. Its molecular formula is pH3. And if we come to its structure, structure of phosphine, its structure is pyramidal, like that of ammonia. If you remember, this is ammonia, NH3. Its structure is very much like ammonia. If we come to its structure is like this. Phosphorus occupies the central position. Then it has 3 hydrogen atoms attached to it. 3 hydrogen atoms through 3 covalent bonds. Now you know phosphorus has atomic number of 15 and electronic configuration of 285. Now it has how many valence electrons? These 5. Now if we look at its structure, this is 1, 2 and 3. So it has 3 valence electrons forming a covalent bond with each of the 3 hydrogen atoms. So now it has as many as these two lone pair of, this is one pair of lone electron. This pair of electron is not taking part in the bonding. So this is the pyramidal structure of pH3. As far as this bond length is concerned, this bond length in case of phosphine is 142 picometer, and the bond angle, that is this bond angle, is 93.6 degree. So this is the structure of phosphine. It has a pyramidal structure. The 3 hydrogen atoms are attached to the central phosphorus atom by covalent bonds. Then we have a lone pair of electron in phosphorus atom. So this is the structure, the pyramidal structure of phosphine. Now let us come to its preparation, how it is prepared. It can be prepared from phosphides. Now which phosphides? We can have sodium phosphide, we can have calcium phosphide, even we can have aluminum oxide. So these are phosphides. So we have metal phosphides. So when metal phosphides are treated with water, we will treat these these phosphides with water and with mineral acid like HCl. HCl is one of the mineral acids. When we treat metal phosphides with water or the mineral acid, phosphines are formed. For example, let me take this. This is sodium phosphide. Let us treat sodium phosphide with water. Now when sodium phosphide is treated with water, phosphine is formed. This is phosphine, pH3 plus sodium hydroxide. Now we can take calcium phosphide in place of sodium phosphide like this. This is calcium phosphide. Reaction with water. Again, phosphine will be formed along with calcium hydroxide. We shall have calcium hydroxide this time because we have calcium phosphide in the reactants. So this was a reaction of metal phosphides with water. Now we can take mineral acid like HCl in place of water. For example, I take calcium phosphide. This is calcium phosphide, but this time we will treat it with mineral acid like HCl. This is HCl. Again, phosphine will be formed. And along with phosphine, we shall have calcium chloride this time. We shall not have hydroxide here. We shall have chloride because we have taken a mineral acid here. Similarly, we can take aluminum phosphide. This is aluminum phosphide. With aluminum phosphide, when aluminum phosphide is taken, we again treat it with mineral acid like hydrochloric acid. We again get phosphine plus aluminum chloride in place of calcium chloride. So we can get phosphine. We can get phosphine by treating phosphides, for example, sodium phosphide, calcium phosphide, and aluminum phosphide with water. This is water, or with mineral acid. So this is one of the methods for the preparation of phosphine. Let me come to second method. In second method, what we do, we can prepare it from phosphorus acid. Phosphorus acid. What we do, we take phosphorus acid. This is phosphorus acid, H3PO3. When this phosphorus acid is heated at a temperature of 478 to 483 Kelvin, in this range, when phosphorus acid is heated, we get phosphoric acid along with our product, that is phosgene. That is phosphine. So this is phosphine. Phosphine has been formed by heating phosphorus acid. This is phosphorus and this is phosphoric acid at a temperature of 478 to 483 kelvins. So this is one more method. Then we can come to one more method. We can prepare phosphine by heating white phosphorus. Let me take white phosphorus. This is white phosphorus. White phosphorus. If we heat white phosphorus with sodium hydroxide and water, this is basically laboratory method, laboratory preparation of phosphine, laboratory method. In this method, what we do, we take white phosphorus, then we pour sodium hydroxide and water on it and heat the mixture, and as a result we get phosphine along with NaH2PO2, that is, this is sodium hypophosphite. So this is another method for the preparation of phosphine. So now we can go to properties of phosphine. First, the physical properties. Let me take physical properties of phosphine. Physical properties of phosphine. As far as phosphine is concerned, it is basic in nature. That is, it has a basic nature. So its basic nature can be tested by litmus paper test. It forms phosphonium salts. pH3, that is phosphine, it has the ability of forming these salts. Which salts? Phosphonium salts. Phonium. With halogen acids. What does it mean? What are halogen acids? Halogen acids are, this is the general formula of halogen acids, HX. Now, if we take halogen acids, with halogen acids, what happens? With halogen acids, it can combine, phosphine can combine and form phosphonium salts. However, this is a chemical property. We shall be going to physical, a couple of physical properties first, and then we will switch back to chemical properties. Now, it is highly poisonous in nature. It is highly poisonous in nature. Phosphine is a gas it is a gas which is highly poisonous in nature, and as far as its odor is concerned, odor, that is smell, it has a rotten fish smell, rotten fish smell, or it has a garlic smell. And then it is heavier than air. It is heavier than air. Then comes its solubility. It is slightly soluble in water, not so soluble. It is slightly soluble in water. Then its vapor density is, its VD, that is vapor density, is 17. So these are some of the physical properties of phosphine. Now let me go to chemical properties. As I just told you that it has a basic nature, and its basic nature can be tested by a litmus paper test. It is basic in nature. So how we can prove that it is basic in nature? We will treat phosphine with the halogen acids. Now what is the general formula of halogen acid? This is the general formula of halogen acids. X for halogen. These are halogen, H stands for acid. For example, this is halogen acid, HCl, hydrochloric acid. HBr is another halogen acid. HI, iodic acid, this is another halogen acids. So we can treat phosphine with halogen acids like this. For example, this is phosphine. Let me treat with halogen acid, that is HCl. When we treat it with halogen acid, what we get phosphonium salts. This is phosphonium salt. This is called phosphonium chloride. Phosphonium chloride. So it indicates that phosphine is basic in nature. We can change the acid here, the halogen acid. For example, we can take hydrobromic acid. Then this reaction will be like this. It will be pH4Br. It was phosphonium chloride in first case, and this time it will be phosphonium bromide. Phosphonium bromide. We can take another halogen acid here, like this, that is iodic acid. Then the reaction will be phosphine plus hydrogen, this iodic acid, and this time we will get pH4I, that is phosphonium iodide. Phosphonium iodide. So your phosphine, when treated with halogen acids, forms phosphonium chloride, which indicates that phosphine is basic in nature. Then let us move to its decomposition, that is its breakup. That is phosphine undergoes thermal decomposition, that is it decomposes on heating at a temperature of 713 K with absence of air. There should be no air, in absence of oxygen or air. So at this temperature, your phosphine that decomposes into phosphorus and hydrogen. So this is thermal decomposition. Then let us move to its combustion. Combustion means burning. It burns with oxygen. This is phosphine. It burns with oxygen. This is oxygen, and forms H3PO4. This is phosphoric acid. phosphoric acid. So what happens to phosphine when it is brought under combustion with oxygen? It undergoes combustion and it forms phosphoric acid. So this was combustion. Now coming to reaction with chlorine. Reaction with this is fourth chemical property. Reaction with chlorine. Let us see what happens to phosphine when it is treated with chlorine. This is phosphine treated with chlorine, and when it is treated with chlorine, it forms phosphorus trichloride along with hydrochloric acid. This is phosphorus trichloride. This phosphorus combines with chlorine and forms phosphorus chloride along with HCl. So this was reaction with chlorine. Then coming to another chemical property of phosphine, reaction with copper sulfate. Let us see what happens to phosphine when it is treated with copper sulfate. This is phosphine pH 3 plus copper sulfate CuSO4. It will be twice and it will be thrice copper sulfate. What is formed in the product? It is copper phosphide. Copper phosphide along with sulfuric acid. So please note that when phosphine is treated with this salt of copper, that is copper sulfate, then copper phosphide is formed and another product is sulfuric acid. We can change the salt here. Suppose we take sodium nitrate in place of copper sulfate. So it will be reaction with sodium nitrate, that is AgNO3. Let us see what happens to phosphine when treated with sodium nitrate. It will be phosphine, that is pH 3 plus AgNO3, that is silver nitrate, thrice silver nitrate. Now see, here in this case copper phosphide was formed. Here we don't have any copper, we have silver instead. So it will be this time silver phosphide. So silver phosphide will be formed. This is silver phosphide Ag3P plus this time no sulfuric acid. Since we have no sulfate salt here, we have nitrate salt. So another acid will be formed, that is nitric acid will be formed here. So this is reaction of phosphine with silver nitrate. Coming to another property with HCl. Reaction with HCl. That is hydrochloric acid. Now this is phosphine with HCl. This will be phosphonium chloride, pH 4Cl. Phosphonium chloride, and if we change the acid here, if we put here hydrogen, this iodic acid, then this will be another property number 8 with iodic acid. With iodic acid we shall have pH 4i, that is phosphonium iodide. This is phosphonium iodide, while as this was phosphonium chloride. And that is all for today. Thank you very much.